So this one's just a little bit tricky. Let's draw a picture first and describe what they're trying to get us to understand here. I always think a picture with the normal distribution is a smart thing to do to try to understand what's going on. So we know zeros here in the middle, and what they're saying is there's this probability that of some z-score being between negative a and positive a. So in other words, from some negative a over here to that same distance, whatever that is, over to here, they're telling us that that area in there is 0.4314. Alright, so that's kind of the start of it. Now, what we have to do, though, to solve this is realize that let's cut the curve in half, right? When we cut the normal curve in half, right through the peak right there, right, we know that it's fully symmetric. If you go this way or this way, it's completely symmetric about that line. So what we know then is that if this is 4314, this total area, then this will be half of 4314, and so will the other side. So we've split it perfectly in two because we're going to be fully symmetric. So 4314 divided by 2 is 0.2157. So what we're saying here is that this little area here is 0.2157, and of course this same area over here is, since it's fully symmetric, this side over here is also 0.2157. Alright, so now what we're looking at here is how do we go find this? Alright, so if that's 2157, let's go find out then what would this area be? Because remember, the calculator, when you do this inverse norm, it can only deal with areas coming from the left. You can't do it any other way. So that area right there is the same, incidentally, as this area. All right, they'd be the same areas. And so if this red line cuts the curve in half, we know that this side over here has 0.5 of area, just like this side over here has 0.5. This half of the curve has 0.5. So if we have 0.5 is the whole half of the curve, and we know that 0.2157 is what's the green shaded area, then the blue shaded area is going to be 0.2843. So this area right here is 0.2843, and then this area over here is 0.2843. Alright, so in other words, what I'm saying here, you could check this if you wanted to. 2843 and 2843 and 2157 and 2157, if you add those numbers up, you will get 1. Alright, and so we've talked about all four of the areas. This blue area, the green, the red, and this other blue, and of course they're all symmetric and equal. Right? Alright, so anyway, that's how we'll do this. So if we want to find this negative a, now we're to the easy part. Now that we've kind of done this determination, you can go to your calculator and either do inverse norm. 0.2843 is one way to do it. You can also look up on the table. If you're looking at the table, it's 0.2843. And so when we enter that on the calculator, you can see inverse norm of 0.2843 gives us negative 0.57. That's this negative a, so negative 0.57, meaning that a has to be 0.57, and that makes it equal to c. And of course you could also do inverse norm and then add up the areas, the first three areas, the blue, the green, and the red, and that would give you positive 0.57 if you did that. And then just to show that here on the tables, if you look at that table and you go look up 0.2843, you see it's right here, and it belongs with negative 0.57. And again, that's just for the proof that it is answer choice C.